Hi, and welcome to InterSystems Virtual Summit 2020. My name is Benjamin, and I'll walk you through the journey that we went on with iKnow from an embedded library for natural language processing in InterSystems Iris, all the way to an open source Python package that's available to anyone to use and contribute to. For today's session, I'll be joined by Aohan, who joined our team right before we embarked on this journey and who played a key role in making it all a success. So first, we'll talk a little bit about why we built this, where we're coming from. Then Aohan will walk you through the different technologies and services that we're using for this whole continuous integration and continuous development workflow that we've set up. And then we'll dive into a demo to show you how it works and how quickly you can take advantage of the new Python library that we're releasing here. So first, let's talk a little bit about why we built it and start off with what exactly it is all about. So natural language processing is really a very broad area. It ranges all the way from super simple tokenization of sentences, cutting it up into words, identifying punctuation, etc., all the way to very advanced automated Q&A bots, such as on a website or at a conference in a true robot that you can really talk to. So all of those involve natural language. So there's a lot of different tasks involved in that area, or a lot of different tasks that are part of this area. And with iKnow, we focus on one particular task, and that is syntactic analysis of sentences in order to extract the concepts, the words that belong together, and their context from natural language text. So what does that mean? What is a concept? When I mention tokenization as a super simple task, it's easy enough to identify the fact that there is a word pain in one of these sentences. It is much less trivial. You need to syntactically understand the sentence in order to identify that this is not just about pain, this is not just about chest pain, but this is about atypical chest pain, which is clearly a trigger to follow up at a clinical level. So that is the task that iKnow performs in a domain-independent way by using the language and nothing but the language. So that's sort of our core activity. Supplemented with some semantic attributes that we identify in a sentence and then identify to which parts of the sentence that those attributes apply. So that's sort of the core premise that iKnow was founded on in 2001 as a small Belgian startup. And we sold iKnow as a standalone engine, so an API that developers could embed in their applications and that deliver based on individual inputs, individual text inputs, delivers those concepts and those attributes to the API consumer. For a lot of the customers that we ran into at that point, they were interested in doing analysis across documents. So those are text exploration scenarios. For example, think about navigating a patient's history or navigating a publisher's archive. So we integrated with several databases, and from one thing follow the next thing. So in 2010, InterSystems acquired iKnow, InterSystems being our primary database partner at that point in time. So from that moment on, we had the opportunity to really embed the library deeply into the InterSystems data platform so that we could significantly increase performance and throughput and convenience for those text exploration use cases. Now, in 2020, after having renamed the technology to InterSystems Iris NLP as part of the InterSystems Iris release, we are now announcing that we publish the iKnow technology to open source again. So we're now offering it both as a deeply embedded solution, part of our platform, and there is a separate session in the health share track that shows you what that can look like. But also now we're making it available as a standalone Python library for use in applications, for use in machine learning use cases. So why did we bother doing that? Why did we make this move into open source? So the first main argument, or the first main reason, is flexibility. I've already mentioned that a lot of the customers that we run into were looking for text exploration solutions. So in order to navigate a patient's history, you have to index all of the nursing notes, the clinical notes, for a given patient, and you keep that in your database so that you can navigate through that information. That, of course, warrants a deep integration with the database, with APIs to browse all of that information. However, if you're looking at machine learning use cases, where you want to use an NLP engine to achieve feature engineering, to extract specific text features, then you are looking at something that acts more as a real-time conduit. So where you're passing in input text and immediately get the features out and then forget about that. So there's no storage component that's required for those scenarios. So we found that there was a need for a little more flexibility in the level at which we were offering these APIs. So that flexibility was one key reason why we wanted to open up a little bit. A second important driver was agility. Some of the most exciting projects that we've executed over the years have been through very close collaboration with our partner or customer, often also including academic, where we learned a lot about how we could potentially improve our language model or how we could tailor it to particular use cases. So there are a couple of features for that already available in the engine. But still, there was an opportunity to have a little more agility and be able to quickly build and iterate with the iKnow library itself, independently of the release cadence of the entire platform. So that agility is also something that we're achieving by going open source, where now anyone can make changes to their fork of the repository, rebuild it from there, following the instructions and scripts that we've published, and also in collaboration with us, if they choose to, get their own customized version of the engine. And then finally, being more dynamic. There's no denying that the whole software market is moving more and more towards open source and mixed source. So this was a great opportunity for InterSystems to also take a first step or a first big leap into the open source space. iKnow was one of the, because of its heritage, because of its technology and status, it made it a good candidate for exploring what that means, also at a technical level, which Aohan will be talking about shortly. But that really gives us the opportunity to get some experience in the open source market. And stay tuned, because iKnow will definitely not be the last thing that we'll be publishing from InterSystems. So with that, let's hand the floor to Aohan and hear how we actually built all of this and what technologies were involved in the process.
Thank you, Benjamin. My name is Aohan, and I will talk about my contributions during this journey to open source. The first question we asked was, how do we expose iKnow to a broader audience? iKnow had always been a highly optimized C++ library, but we wanted it to be available to more than just those familiar with C++. That brought us to Python, which is today's most popular programming language. From a development standpoint, there are a few ways to call out to external libraries from Python, and I will go through the three options that we considered. The first is C-types, which is a Python module that allows for low-level callouts to C functions. After reviewing this option, we decided against using it because it was a bit too low-level for us. The next one we considered was writing a full-blown extension module. Extension modules use the Python API and are quite feature-rich and performant. However, they usually take a long time to develop and maintain, so we considered going with something else. Cython. Cython is a programming language that aims to be a superset of Python and adds features from C and C++. Using Cython, it's possible to write code that uses Python, C, and C++ data types all in the same function. In addition, you can call C++ functions from Python or Python functions from C++. Another feature that we really liked about Cython was that it can automatically convert between Python and C++ data types that are equivalent to each other. There's no need to write custom code to do that. Because of all these features, we decided to use Cython, and using it, we quickly wrote a Python interface to the iKnow engine. Of course, to be an open source project, your source code needs to be published somewhere so that others can see it and contribute. No surprises here, we chose GitHub. GitHub is the leading service for this purpose, and we have our code published in the InterSystems/iKnow repository. Having your source code somewhere is one thing, but eventually you will need to compile it in order to use it. Here at InterSystems, we have a release engineering department that manages the automated building of software. But in this new open source context, this in-house process didn't apply. This is when I discovered Travis CI. Travis CI is a service that directly integrates into GitHub and allows you to automatically build, test, and deploy software that's hosted there. Using Travis CI, I built a pipeline where every time a user submits code to our repository or makes a pull request, we run an automated build. Usually it takes 15 minutes. And once the build is done, emails are sent out if the committer did something that broke the build. Because of this quick turnaround time, we're able to greatly smoothen the development process of iKnow. Another thing that Travis CI is useful for is running unit tests. Our current iKnow unit tests, however, were written using the ObjectScript testing framework within InterSystems Iris. Because of that, these unit tests are not suitable in their current form to put on the GitHub repository. However, we have plans to port those unit tests to the form that can be run by Travis CI. Once that's done, we'll make the development process for iKnow in the open source context even smoother. So now we have iKnow managed on GitHub and built using Travis CI. The next thing we considered was, how do we distribute this to others so that they can easily use it and install it? For Python modules, there's an easy answer for that, which is the Python package index, or PyPI for short. PyPI is a repository where users can upload binaries for Python packages so that others can easily install those packages into their own Python instances using pip. And to make things easy for us, we added the distribution to PyPI, part of our Travis CI pipeline. Every time a developer bumps the version number for iKnow inside the GitHub repository, we trigger this pipeline. Travis CI will build iKnow, build the Python interface, package everything together, including all dependencies, and upload that package to PyPI. Within 30 minutes of this version bump, usually, the new version of iKnow is then available for anyone to install. And now we return to Benjamin to show you how this works.
Thank you, Aohan. So after walking you through where we're coming from and how we actually build all of this, let's take some time to walk you through it and what it actually means to use the standalone iKnow engine. So to do so, I will have to set up my environment, and you could yell at me for not doing that up front, even for a pre-recorded demo, but I wanted to really show you how easy it is to install iKnow. So thanks to all of the magic that Aohan talked you through earlier, you can simply use pip install iKnow py, and that will download the module and allow you to start using it in Python from the prompt from your Python applications. So I'll not go into the Python problem because that's a little too hardcore, but I will show you the demo in the form of a notebook that that contains Python code that we can look at, but it does so in a slightly more usable way so that we can really walk through it. So this is also part of the open source repository, so you can squeeze all of those demos out of that repository. So first, what does it mean to, after installing the library in the first place, what does it mean to actually use it? So you first have to import it, and then you can instantiate an engine object. And with that engine object, you can first check which languages are there, or instruct it to index a sentence. So if you look at the raw output, that's maybe a little dense. So we'll use another Python library, very simple and very popular, Pretty Printer, to just print this output in a slightly nicer way. So here we can see the core information about how we cut up the sentence, how we parse the sentence into a bunch of entities. So different concepts, different relations. We relate them back to the original positions within the source text. And we also emit the attribute information and which part of the sentence that it pertains to. So now let's visualize that information. You can just walk through it in a simple, using simple for loops, or we can use it to make something look a little better and use Colorama, which is a simple package for highlighting stuff on the command line. So still a little bit hardcore, but it also works in this notebook application. So what we'll be doing here is we'll be defining a new highlight function that uses our iKnow engine instance, walk through the output for a sentence, and we'll be adding some color, some Colorama colors to pieces that are negated or certain, and we'll also give a little bit of emphasis to the concept elements. So we'll define that method and unleash it on a simple sentence. And here you can clearly see how not only does iKnow identify that, well, there is a word not in a sentence, but it also kind of expands left and right to the relevant parts of the sentence. So let's use that to look through an RSS feed. So this is today's news. So you can figure out when I did the recording, if you haven't already. And here is how it looks when I actually apply my little highlight function to these sentences. And here you can see that it highlights negation and certainty attributes in a very straightforward way. Okay, that's a nice gimmick. Let's turn into a more practical use. And let's look at feature engineering. So feature engineering is an important step in the machine learning process to turn inputs, the raw input data, into data that's actually useful for a machine learning algorithm. Machine learning algorithms don't understand the text themselves, or the model building ones don't understand text themselves. So you typically have to do some pre-processing to turn it into features that those algorithms understand. And a very classic one is to just use a count vectorizer object that will take input text and translate that into one input text column and translate that into a whole set of columns that each represent the frequency of a particular word. And that, of course, is straightforward numeric information. It's a lot of it's going to be a lot of columns, of course, but that's definitely something that machine learning algorithms can handle. So let's look at what that does with scikit-learn. So scikit-learn includes a couple of interesting data sets. So we'll use that. So what we have here is a bunch of data, a bunch of records like this. And for each of these records, we know whether it's about cars, whether it's about property sales, or whether it's about science. So we'll try to predict those categories based on the text itself. And if you do that, in order to do that, we first have to transform this text into numeric columns. So that's what the count vectorizer class does. And what it ends up with is something like this. So this generates almost 29,000 columns based on that single text column, with frequencies of each word as the numeric values in this data set. So this can be passed on into a machine learning algorithm, in this case, a simple stochastic gradient descent classifier, and we'll then use that to test against test data, and we'll see that we have a reasonably nice precision of 90% of the records that we were properly predicting the category for. So now we will extend this with our iKnow technology. So what we'll do is we'll define, similar to that highlight function, we'll define a new method called strip negation, which looks very similar, but rather than adding color, we're just stripping anything that is in a negative context. So we'll be actually making that that sparse matrix with the frequencies even more sparse by removing pieces that were in a negative context. And then this function will be wrapping that into the sklearn transformation interface by creating a little class that calls our strip negation function. So that's really all there is to it. And now we can put that in a second pipeline. So now, like in the previous pipeline, I'm using my count vectorizer and my stochastic gradient descent classifier. But prior to the vectorization, I'm first stripping off the negation, the negative pieces. And as you can see from this result, we are getting a slightly higher precision for identifying the categories, identifying the news category for our test set. So that was a demo. Let's take a look at an example from an actual customer. So this is these are not my screenshots. These are screenshots from one of our customers who has taken to the Python library and used it in some of their experiments based on COVID-19 reports. Actually, so this is real patient data that they're using iKnow on. So they're using that for feature engineering in a machine learning context, and they have recently published a paper about this in Japanese, and they are really being very thorough in their use of the technology, and have really been in that collaboration, that close collaboration mode that I mentioned earlier on in the presentation. So we're learning a lot from them, and we're trying to help them however we can to make their research successful. Just for wrapping up, I want to show this little diagram that you may have seen in other sessions. We use this to sort of paint the broader picture of our analytics landscape within InterSystems. We are sort of tiering that by different user groups. So information portal is for actual analytics consumers, end consumers, if you will. The data workbench is for people who roll up their sleeves and get going with the data themselves. Application hub is also a set of developer personas. And what we've been talking about in this session was mainly somewhere in between the information portal. Think about that highlight function, and in between those and the data workbench, where data scientists may use NLP to improve the accuracy of their predictive models. In terms of next steps, please check out the resource guide for this session. It has the links to the GitHub repository with the samples we worked through. There's also a link to an online text exploration demo. So that is, this is based on the embedded version of the technology. So for those text exploration use cases that I mentioned at the beginning of the session. And there are, of course, a couple of interesting sessions in the analytics track, and especially the one where you'll get a sneak preview of the intelligent chart review that's leveraging iKnow to calculate HEDIS measure accordance is definitely worth watching. If you have any questions, don't hesitate to reach out through your platform of choice. And with that, I can only thank you and look forward to seeing you on GitHub. Thanks.